Okay, I think we're ready. We're gonna start our summer additive fabrication class today. We've got what is it? Let me look at here. We've got 30 class meetings, more or less. There might be a few that we do different things on. I will be on campus a little bit, so that if you need some physical help with a printer and you are able to bring it to campus, then we can look at it there. We've got the Discord running if you just need some kind of little quick question answered or things like that. I've got a place where you can schedule like a meeting, a Zoom or whatever, if you need that kind of help. But whatever works for you, figure out which way is going to work best for you, and contact us that way so we can keep your printer running as best as possible. We are going to print several things. In fact, why don't we just look through the syllabus to kind of get an idea of what we're going to do. It's on this one that says introduction. So there is right there. So here are 7 different objectives, the kind of things that we're going to do. You can read through those. Required, there aren't many required things. You could, I don't know how well it would work, but you could complete the course without a printer. So I've had a couple of people do that in the past. They just wanted the content and they chose assignments that were not requiring an actual print to be the product. So you could get through the course without a printer, but so it's not required, but it is a whole lot better if you have a printer, or at least access to a printer if you don't have your own personal printer. Let's look at the one I'm using. Well, this is one like the one I'm using over here. This is the Ender 3. It's a pretty basic, this is the most basic of the Ender 3s that you can get. It's pretty basic FDM style printer. So FDM is fused deposition modeling or method, where you've got a roll of thermoplastic of some kind, like this PLA, and you heat it up in here, and it comes out of a nozzle and builds up on the print surface here. So this is about as basic of a printer as you can get that will do the things we want it to do. This one probably is in the, I don't know, $180 range. Usually you can find it for somewhere around that range on a site like Amazon, and there's all sorts of them. This particular one, like you can see, it's an Ender. That's Creality Ender 3. It is not the one you have to get, but it is a good one for somebody who doesn't have any printing experience before and you just want to start printing things. They are certainly more expensive printers out there that you could get, but a lot of times this is all you'll need for most of the things you want to do. Now, if you want to do some very specialized stuff, then yeah, you'll have to go to a higher end printer, but we'll get into that later. So I was saying that because, it has required materials here. And again, highly recommended. I've listed out a couple of others here. This Artillery Sidewinder is another entry-level type of 3D printer. The Ender 3s, I guess I linked here to the one that I bought off of Amazon. I don't know if that link's still active or still the same price even. So assuming you get a printer, then you also need at least one roll of filament to print on the printer. I'm going to use mostly something like this. This is a kilogram of PLA, so that is the filament that we'll mostly use. We don't have to just use PLA. There are many other printer materials that you can use, but they probably aren't the ones you need to start with unless you have a very specific reason. Like if you've never printed anything before, the easiest thing to print and the thing you'll have the most success with is going to be PLA. So that's polylactic acid is what PLA stands for, and it'll be anywhere from $20 to $30 for a kilogram of it. You can get cheaper and you can get more expensive. You're not really looking for any of the specialty stuff right now, like glow in the dark or Woodfield or Copperfield or any of the filaments that are something other than just PLA. I would start with that. In fact, your printer, depending on which one you bought, it probably came with some amount of a test. Now it might look like this, just a little loose spool of stuff. This is two different loose spools, I guess. But it might look like that, which is not ideal at all. It'll get tangled up and create a big problem for you. But it probably came with something like that to start with. Some of your printers, they'll have an entire roll. That might be where I got this, in fact. I don't remember. But you need something to start with. And a kilogram of PLA will do everything that we need to do in the course. Now, you're going to have one color, and that's the color you'll use for the whole course if you don't buy other samples or other filament rolls or whatever. Or find somebody in the course and trade, spool off a couple of meters of yours and trade a couple of meters of theirs, so you have more than one color to print with. I'll do a variety of materials throughout the quarter. In fact, I'll do a lot of different things throughout the quarter. I've got upgrades. Here's an extruder upgrade we'll use. Here's a little sensor that we'll add on. What is this one? I don't know. There's something in this box that we'll do. I don't really know what's in there. But we'll add on a couple of things throughout the quarter, just some of the more common upgrades that you see people doing. We'll mainly do that so that you can see how they work. None of them are required for the course. You can do whatever you want for the course. Leave your printer exactly the way it came, and that will be completely fine. But some people are interested in, well, I want to change the bed, or I want to change the software or the firmware. I want to change the hot end and all these other things. So we'll do some of that stuff so you can see what's involved with making these changes and if it actually is something you want to do or not. I do have an unassembled ender over here that I'll probably go through a video of some of the things of what to look out for when you're assembling, assuming you did assemble an Ender 3. Those same things would happen with other printers of this style also. And so I'll probably make a video of assembling that thing. I don't want to do it in class right now because it takes me about maybe right under an hour to assemble one of these particular style of printers. Some printers come almost completely assembled, and you put 4 screws together and it's done. This one, it probably takes about an hour if I'm videoing it and walking through and assembling it. It probably takes about that long to get it to where you can get it out of the box and printing. And others will take much longer. Others can be a little bit shorter. Most all of them need some amount of assembly, though. It's nothing complicated typically, but there are a little bit of things you have to do. Let's look over here at some of the other things I've written down. I've got a couple of things here. You probably want a fire extinguisher if near your printer. I have never actually had one catch fire, but it does get extremely hot. It's melting plastic. This part down here will get 200 plus degrees Celsius, so that's plenty hot enough to melt plastic for sure. That's the whole point of it. But it does have a heat source that you have to be careful of, and so you'd have one of the dry powder fire extinguishers somewhere nearby. Scraper, that usually comes with the printer these days, and they usually have something decent. A lot of times they are very dull, though, and you have to go and get them a little bit sharper. What am I talking? I don't see a scraper over here right now, but just a little scraper to scrape prints off of the print bed. I also listed this Aquanet hairspray. That's this stuff, right? Let's see if we can get it in the camera. That right there. Well, can't figure out which way to go. I use that to spray either that or just some wood glue, not wood glue, glue stick on the surface of the print bed, actually to keep parts to stick to it a little bit better if I'm having trouble with something sticking to the print bed. This one, if your printer does not come with a spool holder, you might think that you just put this thing down somewhere and let filament unwind from it, and that will kind of work, but there's a really good chance that's going to end up with the filament all tangled up. So you need some kind of spool holder that will, go in here and hold this spool so it can unravel the filament as it prints. Now these Ender 3s, they come with one. It's on top. It mounts on top of the printer, which I don't particularly like. So the one that I have here, you can kind of see this little, this is the filament here. It's coming off. There's a little spool holder off to the side there that's holding a blue PLA. I don't even know what brand it is. But it's holding that over there off to the side, just so it doesn't completely unravel. You can already see this one's a little bit tangled looking. The strands here aren't all nice and neatly aligned. That can give you trouble if it's too tangled. It'll tie itself in a knot. Let's see what else we got in the syllabus. We're going to stream on Monday, Wednesday, and Thursday. Not Monday, Wednesday, Friday. Monday, Wednesday, Thursday. That's, you know, that keeps the Fridays open for other things. About 8 to 9:15 is when we'll go. That's a typical lecture for a Monday, Wednesday, Friday course. Monday, Wednesday, Thursday in this case. The streams will stay up on Moodle and on YouTube so that you can keep them, go back and reference them. In fact, there's old ones there. Maybe you want to get ahead. The course is very similar. You know, I change it every time I teach it, just with the current state of 3D printing. But there are older videos from last summer that if you need to get ahead for some reason, or maybe I talked about something last summer and I didn't talk about it this summer, you can watch those videos. But the ones for this summer will stay up. After I stream them, I'll just leave them up there, unless something disastrous happens, and I'll take that down, I guess. But hopefully that won't happen. We do have a Discord that you can get questions answered in. I try to keep, you know, kind of pay attention to what's going on over there, so that if I need to answer a question, I can. I've got the chat going here. Doesn't look like there's anything in the chat over here, but I have it going. So that if you have a question, you can type it in on the live stream. Here's the course grade schedule. I've got 11 different items here. Most of them are things that you choose. So there's a couple that I choose. So this one, little benchy, that's a little benchmark boat that everyone's going to need to print. It's 5% of your course grade. That one you can turn in over and over. To turn in, since we're doing this online, the turn in part means that you will send it into Moodle. So over here there's I'm not on that page. There's a turn in assignments here link in Moodle, and you can go in there and find the right spot and turn in your assignment. They're all forums where you can upload pictures of the Benji in this case, and a little description of what it is, what assignment it is. So that one you can do over and over again. So you can turn something in, I'll grade it, and then if you think you can do better, you can turn it in again. These calibration prints, there's a set of prints that will kind of help you get your printer printing as best as it can. And those, now I've put these due dates on here, June 10th, August 9th, all that. Those are recommended due dates. Technically, the due date for everything is something like August 10th or 12th, something like that, the last of the quarter. So you could, if you wanted to, wait until the very end and turn in all the assignments. The only danger with that would be, or well, maybe not the only danger, but a danger with that would be that maybe your printer has a failure at that point in time, and you don't have enough time to get all your prints done. So these are recommended, kind of keep you on pace due dates, but they're not actual deadline due dates. They're just when you probably should have this one done. There's a contest link here. So this contest, there will be an in-class competition. We'll pick out a topic. We haven't picked it out yet, but we'll pick out a topic, and you can do that one. Or you can find any contest where you can actually win prizes. And I've got a link. If you keep scrolling down the syllabus, there's a contest section that has places that typically host 3D printing contests. I haven't looked to see if they have any going on right now. But if you want to enter one of those, then that can be your contest. So that's 10%. And then there are 5 of these that are just labeled option 1 through 5. I've got a whole list right here, starting right here, option 1, 2, 3, 4, and 5, of things you might want to try for your options 1 through 5. And you just pick 5 that you think are interesting to you, and you do those 5. It could be that what you want to do isn't listed as one of these things. In that case, I think I have one right here that you tell me what it is you want to do. If it looks like something 3D printing related, then I'll probably add it to the list here, and you can do something that I haven't thought of yet. So there's a whole list of those things that you may want to do, and you do 5 of them. You pick 5. And again, I put due dates that are basically a week or 2 apart to kind of keep you on pace. There are 2 quizzes. They're just in Moodle. They're multiple choice quizzes, general stuff about 3D printing that we'll talk about. And then this last one is a technical brief. It has a section somewhere down here too. Is that it? Right here. It's basically a little 5 to 10 page paper that you write about something. And I've got a couple of different things here that you might want to do. And here's a couple of others down here. It's more or less that it's a little mini report on either a project that you do that has 3D printing with it. So some of these are you have a particular design you want to create, and you describe it, create it, print it, and see how it works. Others are more researchy. Maybe you want to know what's the difference if I print these same parts but at different temperatures. Are they stronger or weaker or any different at all? And so maybe you do something like that. There's some modeling, like CAD modeling things, topology optimization. There's some simulations, SolidWorks thermal simulation, something like that. As long as it has to do with 3D printing, this is more of a end of the quarter research paper type of thing. And so you can kind of, all of this little section talks about what you put in there. And so it's, you do one of those. You don't have to do all of these. You pick one. Let's see. I think that's all of the stuff in the syllabus. The other rest of the syllabus is your regular, just the regular syllabus stuff. These are the things that are interesting right now. All right. Let's see. So I've got my printer already built. You may or may not have already built your printer. Let's look at, maybe you've just now got it out of the box, or you're about to get it out of the box. What do you do first? Well, first you get it assembled. And like I said, I'll probably make a video of that one, assembling it, and just so I can speed up the parts that are not very exciting, and play that one later, next week. But let's assume that you've gotten to that point and it's printed and it's assembled. We're going to start with Cura as our slicer. So a slicer is kind of where you start. Well, maybe not where you start. You actually start by creating some kind of geometry that you want to print. So you go to SolidWorks or Fusion 360, or you scan something in, or you download a part. Somehow you've got this digital geometry, and you want to get it over to your printer to make it into a physical object. And so we'll worry with the geometry creation part a little bit later. I'm assuming you have some ways to do that, but we'll actually talk about some ways that we can create geometry later in the quarter that you might not have thought of before. But let's assume you've got that part. So in between creating or getting that geometry and printing it out as a physical thing is the slicer. And there are many slicers. There's probably like 4 or 5 that are popular, and then a whole bunch of others. And it could be that your printer, they usually come with a USB stick. I don't see one laying around here, but you know what a USB stick is. They usually come with one, and it's probably got some kind of slicer on that stick that you could use. But there are just a few that are the more prominent slicers. Cura is one of those. Now this says Ultimaker Cura. That's because Ultimaker is the company that developed that. Ultimaker is actually a part of MakerBot now, I believe. I believe they merged together recently. But the Ultimaker is a brand of printers. It's probably not the printer you went and bought for this course. That is a little bit higher end printer. These these printers here that they're selling are usually several $1,000s. And our little Ender 3 over here is under $200. But they have Ultimaker Cura, which is the slicer that's going to translate our digital 3D geometry into stuff that can be printed by our printer. And they have it for free. Now, they just released Ultimaker Cura 5.0. It's been in beta for a while, but they just released it as the version of Cura. I downloaded it this morning, and I've got it running in the background, and that's all I've ever done with it. Now, it is picking up some of my printer profiles from previous versions of Cura, so it looks like it's already got printers built in, but it doesn't. Well, let me show you what. So you would go and download for free, and then you would end up with something like this. Let's go over here, I guess. Here is what it looks like after it goes through its intro screens and all that. Now yours won't have this little box here saying Ender on it. That's what I'm saying, that it's already picked up that I previously had some Ender printers in a version of Cura, just not this version. So what you would need to do is go to this little box. Now this one says Creality Ender 3 number 5. So I guess this is the 5th time I've put a Ender on this particular computer. And then there's some others in here. These won't be here. In fact, I don't know if anything will be here. It might be completely blank if you just installed Cura. So what you do is you add printer. So you get this. Add networked printer. You probably won't want to do that, or you probably won't be able to do that. That's probably going to be if you have your printer connected to your home network, your internet. Probably not the way you've got it set up. You probably just took it out of the box, assembled it, and it's sitting there. It might be turned on, but that's about it. We're going to add a non-networked printer. And then it's obviously, this is Ultimaker Cura, so it's going to start with all the Ultimaker printers as the default ones. Again, that's probably not what you have. You probably have a Creality. So we're looking through all, these are all the different brands. Well, not all. These are many of the different brands of 3D printers that you might have. Unless you bought something that was really unique, it's probably in here. Some of these are very small run printers. This Bebo over here, there's not a lot of Bebos out there, but they even have profiles for them. You probably have a Creality. So whoop, there it went, Creality 3D. And then these CR10s, those are bigger ones. That's probably not the one you started with, unless you just wanted a big printer to start with. But here are the Ender 3s right here, and there's 3 listed, it looks like. The Ender 3, that's the one that I'm using. There's an Ender 3 Max, so there's an upgraded version, and then there's a Pro. Now, they don't have the version 2 listed in here, but I assume that you could probably use this Ender 3 Pro, and it would get you close enough. I'm going to use Ender 3 because that's what this little printer is. And if not, you've got all these others that you can list in here. In fact, I believe the very first one, yeah, custom, you could just put the things about your printer in from scratch if you really wanted to. But since they have an Ender 3, we're going to do that. Then it's going to give me this screen. And what I've got here is this X, Y, and Z. Those are the dimensions of the actual printer. So, let me go over here. So the actual X, Y is in this way, and Z is up and down. Those are the, in millimeters, the dimensions. So you could go out and, whoops, those are inches, measure and figure out. Now, you typically can't print all the way to the edge of these beds. You can only get kind of close, but you will be able to input. Now, since it has Ender 3 in here, it's already given typical Ender 3 numbers, and those numbers are right for this printer. Build plate shape, you actually have, I think, just 2, rectangular and elliptic. Pretty much all of you are going to have rectangular build plates. You might, if you have a very different style printer, which we'll look at later in the quarter, you might have an elliptic one, but pretty much you're going to have rectangular. Most of them do not have 0, 0, 0 at the center. Most of them have the origin over here. So not here, but over here for most all your printers. So that's the way it's set up on our little options here. Heated bed. Most of your printers will have a heated bed. That means that this surface here has a little heater underneath here, or it's built into it depending on the style of printer. This surface can heat up. So it can get up to 100 degrees Celsius in some cases. Most of the time you don't need it to get that hot. Maybe you print it at when you're printing your PLA material at 50 or 60 degrees Celsius, but you do have the option to turn on a heated bed here. Heated build volume, that's not going to be most of your printers. That would be assume that you've got the entire printer enclosed in some sort of box, and that thing is heated. There are printers that do that, but they're usually way more expensive than what you're going to start with if you've never printed before. G-code flavors. So G-code is the machine code that the printer reads to do all of its instructions. It's the same type of thing that a CNC mill or a CNC lathe or whatever, like a Haas, something like that, is going to read. The same kind of thing. And there are different flavors of it for 3D printing. Marlin is probably the one, but there are all these others in here. Marlin is the one that we're going to use. It's probably one you should select unless you know a reason not to. Here are some print head settings. These are just basically how far in millimeters is how big is the actual printer head. And let's see what is it exactly saying here. Oh yeah. So sometimes you have dual extruders. We'll look at printers that have that later. This printer has one extruder. The extruder is underneath here. The filament comes out. We'll have to look at a different camera angle to see underneath there. In fact, I think I've got one going right there. Yeah. So right there's where the filament comes out. So sometimes you can have two or more of those things. Maybe you want to have two or more printer materials coming out in your print. So you have a multicolor print or a multi-material print. We'll look at some of that later in the quarter. Pretty much all the printers that you start with are just going to have one extruder, and you don't have to worry about having multiples or whatever. What else is in here? This little start G-code section right here. Let's see if we can expand that to, maybe I can't. I guess it's stuck at that size. This is what G-code looks like, these little lines of letters and numbers. We'll actually get into what all these letters and numbers mean and write some of our own G-code. For now, if you picked one of these that are pre-built, the Ender 3 or whatever profiles here, it's pre-built. You don't have to write this from scratch. Just leave these the way they are. Don't worry about changing them. So there's a start G-code and end G-code. These are little bits of code that are going to be, no matter what part you take apart and slice, your actual geometry, no matter what it looks like, these little bits of code get added on to the beginning and the end. So they're things that you want your machine to do before it starts printing, like heat up the nozzle, heat up the bed. Maybe you want it to go and create a certain type of purge line, or maybe you want it to measure the bed to see if it's flat, all kinds of different things. And then there's shutdown code, the end G code, that once it's done, maybe you want it to go to a certain position, maybe you want it to stay on or turn off, or all these different things. Just leave these alone until you know what to change on them. So, and then there's this extruder 1. This is, unless you clicked that you have more than one extruder, this is where the filament is going to come out. The melted filament is going to come out and create your part. The basic thing here is you should be able to leave these 3 nozzle offsets, XY, and cooling fan number. You should be able to leave those alone. And you should be able to leave the material diameter alone. There are 2 primary FDM, so filament-based diameters. And one of them is 1.75 millimeters, and the other one is around 3 millimeters. That is talking about the actual size of this strand of filament. So this would be the 1.75 millimeter stuff. What it means, the way that this printer works is it's pretty dumb. It doesn't know much. There's a sensor. This one has an add-on sensor. Yours probably won't have that to start with. And there's some thermistors in here that tell you temperature. But other than that, it doesn't know anything. It doesn't know where it's at. It doesn't know how much filament has come out. It doesn't know. It assumes a bunch of stuff. So it knows it told a stepper motor to move. So this can't really. Here's a stepper motor right back there. These little stepper motors are what control all the movement, or what actually create the movement. The controller is down in here in this printer. And it doesn't know that any of that actually happened. So what it's doing is it's assuming a bunch of stuff. One of the things it's assuming is that this is the size of filament that's going into the printer, because it's doing some volumetric calculations that, okay, if I extruded 10 millimeters of stuff that's 1.75 millimeters in diameter, then that much filament volume should have come out of the nozzle. And so I can kind of figure out how much to move all the steppers, how fast to move them, so that I get the part that I want. So that should be 1.75. You probably don't need to change that. So you can leave. I don't think there's any reason you should have to change any of the extruder 1 info, and there's really nothing here yet that you should need to go in and change. We will come in and change this start G code. You can always modify it later. This isn't like a one-time chance to do it. We will probably come and modify this start G code at least, and maybe the end G code before we're done. So then you hit next. You could have renamed it also instead of it giving the... so if you want to go back, here it is right here. You can manage printers. And we can go to these machine settings, and there's all that stuff again. If you need to change anything. I thought I could... if I go to printers, I thought I could change its name, but I actually didn't see where I could change its name. It won't let me change it there. There's more of that G code though. There we go. Rename. So it's a little hamburger thing over here. Let's call this one, just so I can keep track of it, Summer 2022. Creality Ender 3. All right, that way we can find it in our list of printers over here. So at that point, now you've got one printer installed. This little window right here might not be open. And so it'll give you, this little box is based on that 235 by 235 by 250, the X, Y, and Z size of the printer. This is basically the part that you can put into your printer. And I have got these extensions right here. I've got one called Part for Calibration, where I can just plop in different parts. This won't be in your version of Cura unless you have already ran Cura for a while. I would recommend adding this one. You go into this marketplace over here, which I haven't looked at in Cura 5, so we'll see how long it takes. It was actually pretty fast. What these are little plugins that people have written that add extensions to Cura. Let's see if I can find Calibration. Calibration Shapes. So Calibration Shapes 2.0.1, mine says uninstall. Yours will say install if you've never installed it. I would recommend doing that one because it does give you, you don't have to go find certain parts. If you just want to print a calibration thing really quick, it'll just put it into your printer. So that's a good one to have on hand. Let's see if I've got any others in here. I think these are all, yeah, these three are all ones that come in Cura, and Part for Calibration is the one that adds these things. So I'm just going to put a calibration cube in here, just so we have something. So this is, you can download these things, but this way it's just already there. You don't have to go try and find it. What this is it's a 20 millimeter by 20 millimeter by 20 millimeter cube with the letters X, Y, and Z kind of embossed in it. And what this is good for is you can print these things. First, it'll tell you that your printer is actually printing. And then it will also, you can measure them to see, well, is it printing the right size? And you can kind of get an idea of the quality of what it's doing. So this would be the 3D geometry. This geometry isn't any good to the printer. The printer needs that G code stuff. So it needs this thing translated into G code. And the idea is that this is called a slicer, right? This piece of software is a slicer. And what it does is it takes little thin slices of this part, translate them into G code movements, and spitting out filament, extruding filament to create this part. All of these settings over here, and when you click on this, you get a bunch of others. are little bits of information that control how that slicing happens. So there's a whole bunch of stuff. This is nowhere near all of them. This is the simple version of the slicer settings. There are, let's see, you can do the all slicer settings. I don't even know if I want to click on this, but let's click on it and see what happens. So it's just pages and pages of every possible thing that you might want to change about how this geometry gets sliced into little layers that will be printed. I'm not going to, let's go back to custom. All right, this is good for now. Actually, let's start with basic, because that'll be what you have. You have basic, which is very similar to what the custom was on there. All right, so these are the ones that are the most important. So probably the single most important one is this one called layer height. And if you hover, you know, if you leave your mouse over any of these things, it'll Cura will pop up a little description of what it's talking about. But this layer height is how thin are the slices of this part going to be. So obviously, the thinner they are, the better, assuming your printer can handle that thin, the better your part will look when it is printed, within reason. There are some limits on that. The limits are typically this nozzle size. So let's see if we can go back over here. There's a little, let's see if I can find it. There it is. There's a little piece of filament coming out of there. So the size of that nozzle is typically 0.4 millimeters. Unless you've changed something or you bought a special printer or something like that. Most of these style printers, that nozzle hole, the orifice, is going to be 0.4 millimeters. So knowing that, well, let's get off this. This layer height has some limits. Typically, the layer height limits are 25% to 75% of whatever that nozzle diameter was. So that the minimum is about 25% of that nozzle diameter. The maximum is about 75%. Now you can force it to do other larger and smaller, but that's generally a good range. So it's set by default at 0.2 millimeters. So 0.2 of a millimeter for every layer. That's every layer will be that thick. That's probably a good compromise. You can go up to 0.3, 0.28, something like that. If you want to print a little bit faster but coarser, you can go down to like 0.15. When you could go down to 0.1, but that creates some other problems. If you wanted to get higher resolution, but it's going to print a lot longer because there's a lot more layers to print. 0.2 is probably a good starting point. So I would leave that one alone. These walls, the most important one here is this wall line count. So that's perimeters. How many outside perimeters are there going to be in the part that you print? Typically 2 is what you want. If you want a part that's going to be stronger, you know, it's going to have to endure some stress and strain, then maybe 3 or 4 walls. If it's just for decoration and it's not really going to do much, you could probably get away with 1 wall. In fact, we'll talk about a way to do a special single wall print later on in the course. But 2 is probably good for most of just having the part and handling it, but it's not going to really be strong, but it's not going to be weak. It's just kind of average part. So 2 is probably good there. Top and bottom layers, these are talking about solid tops and bottoms of the print. You typically have these things are hollow on the inside, so they're not solid blocks of plastic. They're hollow on the inside. If I'm just trying to print something kind of quick, then I'm going to drop this down to maybe 2 or 3 top layers and 2 or 3 bottom layers. The more top and bottom layers you have, the better it will look in the end, particularly the top layers. But we're gonna try and get this done relatively quickly. So 2 top and 2 bottom for a not strong but usable, or at least something you can handle. Infield density. So like I said, these parts when we print them typically aren't solid blocks of plastic, and I usually this isn't exactly the percent material to air ratio. I mean, it's that idea, but it doesn't, like if you measured it, it wouldn't come out that way. I usually drop this down to 10 or 15% if I just want a part that I can handle, but it's not necessarily going to be strong. Throughout the whole quarter, we'll talk about why you want more walls or higher density, or what if you only want higher density in a certain spot. We'll do all that later. We're just trying to get a part to print first. Printing temperature at 200, that's a decent starting temperature for PLA. You might go up to 205 for some material, PLA material, but I'm going to leave it at 200. Build plate temperature, 50, that's a good temperature for PLA. Print speed, 50 millimeters per second. That's a little bit on the slow side. I'm going to go up to 70. This printer should be okay with 70 millimeters per second. This print cooling. So here we got to look at stuff on the printer again. Not that version. This view. So there's two fans on this printer. There's one here and there's one on this side. This fan should just be on whenever it's printing, because what this fan is doing is it's keeping the actual hot end, the part where the filament is being melted. There's one side of that, and we'll look at all this later. There's one side of that needs to stay hot, the 200-degree side. The other side of it doesn't need to be hot, because if you melt your filament all the way, way up in here somewhere, then you're not going to be able to push it out of the nozzle. It's going to be kind of too gooey to do anything with. So this fan cools off the cold side of our hot end, so that our filament isn't gooey in here. It's only gooey down at the bottom. This one is what we're talking about in here. This, where's it at? Cooling. We do want to enable print cooling with PLA, and we want this fan speed at 100%. So PLA is one of the materials that it needs to cool pretty quickly, or else you'll get really lumpy, ugly looking prints if the PLA isn't allowed to cool. And so this little fan on the side of this printer goes in and it blows cool air onto the recently printed PLA so that it can cool off fast enough so you can put new PLA on top of it. Other materials don't like that as much, but PLA does like that. We'll talk about this support setting later. This block does not need support, so we'll leave that off. Build plate adhesion. One of the biggest problems you're going to have starting out is you're going to be printing something and it's going to come off of the bed, or it's going to peel up from the bed, or whatever. And so that's one of the first things you got to figure out, is how are you going to get your prints to stick to the bed. That's also why I have the oops, where did it? That's also why I have these things. That helps. Cleaning the bed is probably the first thing to do. Let's say that you're in your print and you just can't get anything to stick. So the things you need to do first are make sure that this surface is as clean. Now this one doesn't at all look clean, but clean it with hot soapy water. So most of these you can unclip the little surface here and take the surface off. If you can't do that, then you'll have to be a little more, you can't just put water everywhere. There's got electronics all around this thing. So you have to use something else. But assuming you can take the surface off, take it, get hot water, soapy water, and clean the thing. And then don't touch it. Your finger oils touching on here are one of the main reasons that parts don't stick. So once you've done that, if you still don't have prints sticking down, it could be that your nozzle over here, nozzle is too far or too close to the bed. So too far away or too close to the bed. So there's a little bit of adjusting that has to be done to deal with that. Usually that adjusting is done by turning these knobs right here. There's 4 of them on this printer, one here, one on each corner. So we'll have to figure out, we'll do that in a second. Let's see, what time are we at? Yeah, we'll do that in a second. The other things you could do, like I said, you could spray hairspray on there. You could put glue stick on there. If you're doing the glue stick version, I would wait till your bed heats up a little bit. It'll be a lot easier to get the glue stick smooth and not so lumpy. Let's see. You also have these options here. So these are things that you can print that will help your part stick. So skirt, brim, raft, or nothing. So I'm going to do the skirt one. This doesn't help the part stick at all, but it helps. It gives me a little bit of time to watch the print before it starts printing the actual part and adjust things. Plus it will do a little bit of a purge so that the nozzle is clean and clear of anything, and I've got filament flowing out cleanly. Brim, this is sometimes useful when I've got a really tiny part and it doesn't have a lot of surface area sticking to the bed. So a brim just adds surface area. So it just adds a brim, like a hat brim, around the part. Raft, maybe there's something with your bed that is really lumpy. It's got, it's uneven, it's not flat, but you want to print this big part on it. You can use a raft it's going to take a lot longer, right? Because it's going to have to print this thing, but it will print a surface on top of your surface that your part can stick to. That's kind of my last resort. I don't normally want to do a raft, but it is an option. There are sometimes you need to do it. Again, with really tiny parts, sometimes a raft is the best way to do that. We're going to do skirt. I don't know why dual extrusions on here. Dual extrusion means that I have more than one nozzle on the printer. This printer doesn't. So I left everything the same except I changed the top and bottom to 2 layers, but just to speed up the print. I lowered the infield density, and I sped up the print speed to 70. You can almost always get better prints by lowering the print speed to 50 or 40, something like that. I wouldn't go too much lower unless I'm printing a special material than 40, because I don't think you gain much beyond that. If you do, then it's probably something hardware related on your printer that's loose or rattly or something like that. All right, so we get all these set, and then we do slice. I'm going to close this. All right, so what it did is it went in there and it took this geometry and it made it into a bunch of slices. If you want to see the slices, which is always a good thing to check, you click on this preview and it shows me the slices. So the colors actually mean different things. I don't remember exactly what all the colors mean, but red is outer wall, green is inner wall, yellow is top layers. There's our infill orange. So you can kind of see this is our infill. I put it at 15%. So you can kind of see these orange lines in here are how it's not completely hollow, but it's not solid either. And there's my 2 walls, the green and the red. You can kind of see I put 2 walls on there, so that's what the 2 of them are. And then if we look at the 2 bottom layers, there's one. So they're going in opposite directions. And then I put 2 top layers, one there and one there. 2 top layers is not really enough, but it'll do for what we're going to do here. This little white line of dots here, this is what's called the Z-seam. Each one of these layers had to print, and then the nozzle moves up and it prints a new layer. So it has a start and a stop point. This is where it aligned all of those. Sometimes this little seam can be a little bit bumpy because it's a start and stop. We're not going to worry with that just yet. It's going to be on this corner and it'll be fine. All right, now what I do is, so this printer has a little SD card down here, little micro SD. I don't like it's too small, but that's what it's got for now. I'm going to put our sliced file on this SD card. So I'm loading it in the computer. Let's go back over here. Now it changed to save to removable drive. Cura usually recognizes whenever there's the files that are on there now. Whoops. Gotta get all my screens back. I closed them accidentally. There's that one. That's probably good. So it usually recognizes that there's a SD card or a thumb drive added in, and it'll save to it. So we'll save to it. It says it's going to take 24 minutes, so we'll start this one. I'm not going to sit here and watch it print for 24 minutes, but we'll start it. Then we'll eject our file. And then let's go back to our printer. Let's get my card here. I didn't even, let's see. It's called Untitled, so you could have named it something better than Untitled. Here's our power on. That little clicking was this sensor checking that it was okay. Now this one's running a little bit different firmware, so I'm not going to be too worried with the screen over here. Hold on. I think our screen, let me there we go. It would have frozen up on us. All right, so we put the SD card in here. You control everything over here. What I was saying is that this one I've changed the firmware on this one, so your menu is going to be a little bit different than what this menu has, but they're all very similar. So you click the button and then scroll it to get to different things. Usually you scroll all the way down and it's print from SD or print from card or something like that. Click that, and then you'll have a list of the different files on the SD card that look like stuff the printer can print. So ours is called Untitled. So I will print that. And then it gives me little messages right now. Oh, it's locked up again. Not sure why it's locking up on me there. Didn't want to keep running. Maybe we'll have to switch to the other camera. Let's see. That one's running. All right, so actually this one will show us more of what's going on anyway. So what it's doing is the bed is heating up right now, and I know I'm touching the bed and everything, and I just told you not to do that, but we'll hope it's okay. So this one has already been leveled. Now, if you didn't go through and do that as part of the assembly process for your printer, then that's probably going to be the very first thing you need to do instead of jumping right into this printing. What leveling means is you're going in, you're adjusting these screws so that this surface here is not like level, like a bubble spirit level type thing, not necessarily level with the ground, but parallel to all of the stuff that's going to be moving around. And so you go in, and I do have a video that's just about leveling the bed. I think I put it in Moodle. I'll try and see if I can link it to the description of this video, just because that's a pretty important thing to get doing first, so that your print has a chance of sticking down to the print bed. So what it's doing now, the extruder is heating, and it gives you little on the panel over here. It gives you information about the current state of the temperature of the bed and the nozzle. So we're at 88 degrees on the nozzle and 50 degrees on the bed, and we told it to go to 20 degrees on the nozzle, so it's going to do all of that before it starts printing. I usually have some kind of pliers, which I don't seem to have right now. I do have these guys, so just to, sometimes this will start oozing, and we'll get that out of the way. So we're at 144. Now this firmware has a feature called baby stepping enabled, which I am currently, you can kind of see the nozzle is, or this whole hot end is slowly moving up. That may or may not be enabled by default on your printer. We'll actually show how to enable that later when we get into actually changing the firmware on your printer if you want to. But some printers have that enabled, some printers don't. It's called baby stepping, and what it does is it lets you change the distance between the nozzle and the bed. So is leveling process different for the Ender 3 with the BO Touch versus stock? So this one does have a BO Touch on it, and it is different. You still want to start with as flat of a surface as possible. So I still go through the manual leveling, even if I have a BO Touch on there. So all right, I'll get back to that. So here it's creating a little purge line, and that actually looks fine. So I'll maybe make it a little bit closer. We'll see what comes out over here. Actually, I'm raising the nozzle a tiny bit. You can't even really see on the screen what it's doing, but it's I'm looking at the what's being printed, and it just looks too close to the bed, like it's too smushed. So it just printed the skirt. Now it's starting to print the actual part. All right, so we'll let it do its thing while we talk over it for a little bit. So it's actually printing the first layer right now. So to answer the BO Touch question, let me talk about the BO Touch for a second. That's this little, well, it's on the screen right now. It says BO Touch on it. What that is, it doesn't come stock on all printers, but some do. This one was added on. And we'll actually add on this guy later on. We'll add this, oh, where are we at? CR Touch. We'll add it later. But what it does is it's a mechanical probe that goes in. You saw it probe when we did the homing routine. It can actually be coded to probe the entire bed so that you can get a sense for how flat the bed is. Not just that it's level, but it's not got hills and valleys in it. And if it detects hills and valleys, it can go in and your software can adjust dynamically the distance between the nozzle and the bed so that your nozzle's moving up and down as it prints, so that you can account for an unflat bed. So that's what it can do. The question was, is the 11 process different though? I'm going to say it's not, because the same idea is you want to start with as flat as possible. And so the leveling process that I did with this other video that I talked about, that it's in Moodle, and again I'll try to put it in the description of this one too, is that you're getting the nozzle distance from the bed set at all four corners in the center as best as possible without the aid of the BO Touch or any of those sensors. There's a lot of these sensors that do similar things. So without using any of those sensors, you're getting it as close as possible. So it looks like our little part stuck down. You can kind of see it. I don't know if I can get any light on there that makes it. There it is. So it's down in there. It's printed a couple of layers already. You can kind of detect some of the infill in there. I don't know if this other camera has decided to come back on or not yet. Let me see if it's, no, it's still stuck for some reason. There's kind of an overhead of what it's doing. Look at that view for a little while. Now I told it to print 70 millimeters per second. It's not actually going that fast, so that's its maximum speed, but this little part is only 20 millimeters long, so it doesn't have time to actually get that fast. So there's an acceleration also, and a acceleration, a speed, a jerk. So jerk is the derivative of acceleration. Acceleration is the derivative of speed. And so you can control all of those things. I would not recommend changing any of those other than speed until you've gotten much more familiar with what the printer is. We'll actually talk about how to optimize some of those later. But for now, just leave the accelerations and jerks the way they are in the default, unless you're having to build your profile from complete scratch, which you really shouldn't have to do, but I guess it's possible if you have a really unique printer. So over here, this is back in Cura. It looks like we're down maybe, I don't know, right in that area somewhere currently, so somewhere around layer 7. It says we're 11% done on our print. And you know, you can kind of get the idea of it's printing 2 walls and these little orange infill layers. When we get to, there we go, level 28, you can kind of see it starting to make the shape of the letters on the sides. So you can kind of see it's building up layer by layer over here. And this is kind of a typical printing speed. this might be slightly faster than you would print something that you wanted to come out really nice. But I did print one of these. Here it is. I printed one of these on this printer yesterday. Actually, this one doesn't have the letters on it, but I mean it's decent. Oops. You can, in the camera and the light shining directly down on it, you can see some of the unevenness in the layers, but it's very minimal. I think it was actually this way. It was top. You can kind of see one strong line in there. There's a little pointer. Well, this will do. You can kind of see one right there that's a little bit stronger than the others. That one actually is probably something binding up on the printer. The way these printers move is all controlled by, let's see if we can look at the overhead one. Constrained, not controlled. Controlling is the controller down in here. The motion happens by these steppers, and then it's constrained by these rollers here. And it could be, these are just like, I don't know, polyurethane rollers or something. I don't know what they're actually made of. But they're a rubber-ish, you know, really stiff, but rubbery material. And it could be that one of them is too tight. I don't think any of them are too loose, which might be the thing that you would need to worry about when you first assemble your printer, is that some of these are too loose. But there could be one that's too tight, and it's kind of constraining the movement a little bit. We'll check on that later. How you adjust these, though, is they're all in sets of 3. So 1, 2, and then there's a third one down here that's underneath this guy. One of them, this one, and the bottom one on these 3, has what's called an eccentric nut. So it's not concentric, it's eccentric. And you get these little wrenches, which let me get my little tool kit here that's got some wrenches in it. Here's one. Well, this is actually a bigger wrench. Well, you get a little wrench. This is not the kind you'll get. Yours will be just a stamped piece of metal, but you should get one in the printer kit that will fit these. And you turn them like you're tightening or loosening them, but you're not actually tightening or loosening them. What you're doing is you are moving them in their kind of little orbit in that eccentric nut. And so that pulls them in or out from the rail. So if you have anything that's too loose, like you can jiggle things around the bed, or the nozzle is kind of loose, or this bar is loose over here, then you can adjust that by tightening, well, by moving, not necessarily tightening, by moving these eccentric nuts, and you move them like you would move a, you know, a tighten or loosen a nut. And there's also, I think there's actually 2 underneath here under the bed. I can't, yeah, it has a set of 4 underneath it. So 2 of those are eccentric. Let's see, 9:03, so we're getting close to the end. It's not going to finish our print. Let's see how it's doing. Oh, I moved it. There it is. Still doing okay. You can start to see the beginnings of the letters in there. That's the X. This is a decent first print. A lot of people, one of their assignments is to print a benchy. The problem with the benchy is that it is going to be a longer print on normal settings, like maybe even an hour. Now, you can look up Speedboat Challenge on YouTube, and you can find people printing benchies under 8 minutes, 4 minutes benchies or whatever. They don't look as good as what we're aiming. Our goal isn't to print it really fast. Our goal is to print it well. But I wouldn't start with that one just because it takes longer. This is a good one because it's 20 minutes, and you can measure it afterwards and see if your printer is printing correct dimensionally. It should be. There's not a lot of reason. If it's not printing correctly dimensionally, then you probably have one of your belts loose, or one of those wheels is just really, really tight. It's probably a belt that's loose, though. Typically, once you've assembled these things, this is the hardest one to get tight, just because you know, unless you have another person there helping you, you've got to hold it, tension on it, and tighten it up all at the same time. And so that can be difficult. And if this is loose, too loose, then when you're moving back and forth here, you can get some slop in the print and it won't come out the right dimensions. Or it'll be kind of wavy or something like that. If it's printing your block and some of it is like shifted over, then it could be this one's belt. Now this belt is usually pre-assembled on most of the printers, so you shouldn't have to do anything with it. But either you're printing way too fast, or this belt here is loose and the bed is losing track of where it's at. So it's what's called skipping steps. So again, these are stepper motors that are the little motors that drive everything, and they take discrete steps. We'll talk about all that later too. And it doesn't know that it actually took a step. It just knows it told it to take a step. But if something skips, like the belt is too loose and it skips on the stepper motor, drive wheel, or whatever, then it doesn't know that, and so it just keeps printing, but everything's offset by however much it skipped. So those are some things that you might want to look at. Very first thing, assemble the thing. Then level the bed. I'll get that video connected to this one somehow. It is connected in Moodle already. And then as you're printing, now mine worked pretty much just right, but what you might have to do is, remember I added this skirt over here. You can kind of see the edge of it every now and then. You might add more lines to that skirt. In fact, let's look back at here. Let's go back to prepare and let's look at that skirt. Here I've got skirt listed, but it I'm on the simple version. Let's go to well, let's just type in skirt here, and here when I can search for particular things. Generally you're not going to know the names of everything to search for, but if you type in the name of, in this case, skirt, it gives me, hey, there's these other things I can also control about skirt. So I can have more lines. Instead of just doing 3 laps around the part, I could do 10 laps around the part. But this skirt is good for kind of before your print starts, the actual print, but while it's running, the printer is going, then you can adjust these nozzles, these knobs to get your height just right. I was using this because this printer has baby stepping enabled, and I don't know if your printers are going to have that enabled or not. You can check that. Usually how you activate it is when the print starts, maybe while it's doing this purge line or whatever, if you double click this button, that will usually activate baby stepping if it's enabled on your printer. It could be that it's in the menu, like in a tuning menu. After the print starts, there might be a tune menu. You can change temperatures and speeds, and sometimes you can do baby stepping in there. Or maybe it's called Z offset sometimes. Live Z adjust is another thing I've seen it called. And so there are some ways that you can go in there and change it there. But typically, if you get that bed leveling set right before you even start printing, then you'll have a much better luck. Maybe just doing a little bit of fine tuning as you actually watch the print. What you're looking for is you want the filament that's coming out to not be squished completely flat, but you don't want it just laying on the surface either. So you want it somewhere in between those two. See if we can look at this purge line. If I can peel it off of there without destroying everything else. So let's get it up here. So I'm gonna have to turn off autofocus. All right, so see how it's a little bit flattened? I don't know if it'll focus that close. Maybe it'll focus here. Kind of. Every now, there it goes. All right, so see how it's kind of flat and a little bit wider. This is 2 lines side by side, by the way. That's kind of what you're looking for, is something that it's not round, like it's just dropped onto the surface, and it's not transparent unless your filament is transparent. You know, it's not so thin that you can see through it. And so that's what you're looking for to get a decent combination of being squished enough that it'll stick down, but not just laying on the surface of the thing. And so that takes a little bit of practice on figuring out just how thick to get that first layer. So you'll have to try to print some things to get that to work. I think we're pretty much at the end. So next week, the Monday, Wednesday, Friday, I think I'll have a video for building. We've actually got, let's see where our syllabus is over here. Got a couple of things. Oh, wait, not that one. There we go. So there's where you turn in the assignments. We've got to look at that for a second. So there's where you can turn in the different things. You create a thread with your assignment that you're turning in, a little description of what you did, and upload that. And most of these optional ones, I'm not going to grade as far as, not going to go and look at your surface finish quality very much. You know, I'll look at that to the point that it's good or really, really bad. If it's really, really bad, then I'll take up some points off on that. But most of these are going to be very subjective, right? You know, if it's good or not. So I'm not going to do too much on grading that it's good, as long as it's complete. The technical brief, it gets graded like our lab report. The benchy here, it gets graded, you know, how good do your lines look? Do you have blobs? Do you have strings? Do you have all that kind of stuff? In fact, there's a rubric for it right here that you can look at. Here's our in-class competition. We need a theme. So if anybody has an idea for what the theme should be, last year it was puns on the rock. So like the character, the rock, you had to mix a basically a bust of the rock with some other thing to make a theme, a pun about something. So we'll come up with, that's not our theme this time, but if you have an idea for a theme, then we'll put one here. This will be towards the end of the quarter. Here's kind of a list of where we're headed. These aren't necessarily exactly what we'll talk about, just because something might be more interesting at a, you know, I might want to move something up or down, whatever. But this is generally the type of things that we'll talk about throughout the quarter. If you see something or don't see something, you see like, I want to know about whatever, feel free to let me know, and there's probably a place that I can put it in to some of these things. You know, a lot of this class is a lot more fun if y'all are interacting with it versus just me talking to a screen. So next week, what I was saying though is that it will be a little bit different, because I don't know that I'll be able to do those live, because I've got, at least not Monday and Wednesday, I've got a summer camp that I'm doing, so I won't be able to do this one because they overlap at the same time. So I won't be able to do those live, at least not live at 8. So if I live stream them, that'll be a very different time, and I'll try to let you know when I get a chance to do them. It might be that they're pre-recorded though, or you just, I'm live streaming it and I just have to tell you, hey, I'm doing it in the next 5 minutes. They'll all stay online though, so you won't miss them. It just, they may be hard to do live for class 2, 3, and maybe 4. Anyway, I think that should get us starting, and see, let's see how our print's going here. It's almost done actually, but we're out of time, so we'll come back next time, and that'll be the first thing we do, is we'll look at this print and kind of go through what does it look like, and does it tell us anything about how our printer could be improved. Maybe I'll even intentionally make some bad ones, so that we can see what shows up whenever you've got a loose belt or you're printing too hot or something like that. So check back for that next time, and I'm going to try and find the video that talks about leveling your bed, because that's a really important thing to do also. And I'll see y'all next time.